There's a number floating around the AI industry that nobody likes to say out loud. Roughly 95% of AI agent demos work, and roughly 95% of AI agent deployments fail. Same model, same prompts, same tools. The demo flies. The production system collapses. So, what's actually happening in that gap? Most people assume the answer is a better model will fix it. It won't. I've watched teams swap from one frontier model to another, top of the leaderboard, and watch the same agent fail in the same places. Because the thing that separates a working agent from a broken one isn't the brain, it's the body. And almost nobody talks about the body. In this video, I'm going to walk you through the 5-layer architecture that production agents actually need. None of these are model features. All of them are scaffolding you have to build around the model. If even one is missing, the whole system gets fragile. And once you see the pattern, you'll spot it in every agent product that works and every one that doesn't. Let's start with what people get wrong. When somebody builds an agent demo, they usually wire it up like this: a model, a few tools, a loop that says think, act, repeat. They give it a task, it does the task on camera, everyone claps. The reason the demo works is because the demo is one task, in one environment, with a clean starting state, and a developer watching the whole time, ready to intervene. Production has none of those properties. Production has thousands of tasks, weird environments, dirty state, and nobody watching. So the question becomes, what do you have to add to that simple loop to make it survive contact with reality? The answer is 5 layers. I'll go through them one by one, and you'll see why each one exists. Layer 1 is tool sandboxing. In a demo, you give the agent your real credentials, real database, real API keys, real file system, because that's what makes the demo impressive. In production, you cannot do this, not because of paranoia, because of math. A language model is, structurally, a system that cannot reliably distinguish your instructions from instructions hidden in the data it reads. So the moment your agent reads a web page, an email, a PDF, a customer support ticket, anything containing text from outside, that text can include instructions, and the model will sometimes follow them. This is called prompt injection, and it's not a bug that gets patched, it's a property of how these systems work. So sandboxing means every tool the agent can call has its blast radius capped. The database tool can only read, not write. The email tool can only draft, not send. The shell tool runs in a container that gets thrown away after each task. When the agent goes off the rails, and it goes off the rails inside a box that doesn't matter. Without this layer, one bad task can do permanent damage. With it, a bad task is just a bad task. Layer 2 is context and memory pruning. Here's something you might not have noticed about long-running agents. As the conversation grows, quality drops. Not linearly, sharply. Around 30 to 50 turns into a complex task, most agents start hallucinating tool calls, forgetting what they decided 5 steps ago, and looping on the same wrong approach. The reason is that the context window fills up with old tool outputs, half-finished thoughts, and error messages that no longer matter. The signal-to-noise ratio collapses. The fix is active context pruning. After every few turns, the agent, or a separate process, summarizes what's been done, what's been learned, what the current state is, and replaces the long history with that summary. The verbose work disappears. The compressed lesson stays. This is the difference between an agent that can run for hours and one that gets dumber the longer it tries. If you're building anything serious, ask yourself, who is in charge of pruning my agent's context? If the answer is nobody, that's why it fails on long tasks. Quick re-anchor. We've covered sandboxing, the safety layer, pruning, the memory layer. Now we get to the layer most teams skip entirely. Layer 3 is failure recovery. In a demo, when something goes wrong, the developer hits stop, fixes the prompt, runs it again. In production, nobody hits stop. The agent has to handle its own failures, and the failure modes are weirder than you'd expect. There are three categories. Tool failures, where an API returns an error the agent didn't anticipate. Reasoning failures, where the agent gets stuck in a loop or pursues a clearly wrong direction. And environmental failures, where the world the agent was operating in changed mid-task. A file got deleted, a page layout updated, a permission expired. Each one needs a different recovery strategy. Tool failures need retry with backoff and a fallback path. Reasoning failures need a watchdog, usually a separate, smaller model that observes the main agent and intervenes when it sees a loop or a clearly wrong trajectory. Environmental failures need regrounding. The agent stops, rereads its environment, and decides whether the original plan still makes sense. A production agent isn't an agent that doesn't fail. It's an agent that fails, notices, and recovers. If your agent has no notion of notice and recover, it isn't a production agent yet. It's a fragile demo. Layer 4 is cost and loop guards. I want to make this concrete. A team I know set up an agent to run continuously, monitoring a queue of customer requests. They tested it on a small sample. It worked. They turned it on for the weekend. By Monday morning, the bill from their model provider was over $4,000. The agent had encountered a request it couldn't complete, retried the same approach in a loop, and burned through credits for 48 hours straight. Nobody got an alert. Nothing crashed. It just spent money. Cost guards are not optional. The minimum set is a hard maximum number of steps per task, a hard maximum spend per day enforced at the provider dashboard, not just in your code, and, this is the one most teams miss, model routing. Not every step needs your most expensive model. Classification, summarization, simple tool selection, those run fine on a smaller, cheaper model. Routing intelligently can cut your costs by 60 to 80% without touching quality on the hard steps. If you take one thing away from this section, the agent that costs you money quietly is the dangerous one. Loud failures are easy. Silent failures bankrupt projects. We're at 3 layers down, 2 to go. So far, we've built an agent that's safe, that remembers what matters, that recovers from failures, and that can't burn you alive on cost. What's still missing? What's missing is, how do you trust what it produces? Layer 5 is verification. This is the layer almost everybody skips, because it feels like a step backward. The whole point of the agent was to save time. Now I have to verify its output? Yes. And here's the secret. Verification is not the same as redoing the work. Verification is structural. You're not asking, is this right? You're asking, does this pass the check we agreed on? For code generation, verification is, does it compile? Do the tests pass? Is the diff scoped to what we asked for? For research outputs, verification is, do the citations exist? Do they say what's claimed? Is there a date and a source for every factual claim? For data tasks, verification is, does the math reconcile? Are the totals consistent? Does the output schema match expected? The verification layer is usually run by a separate model, a smaller one with a simpler job, or by deterministic code. never by the agent that produced the output, because that agent has every incentive to confirm its own work. The verification layer is the difference between the agent produced something and the agent produced something I can ship. Now here's the hidden insight, the thing that turns this from a checklist into a worldview. These 5 layers compound, they are not independent. Drop any one of them and the others get weaker. Without sandboxing, your verification layer can't be trusted because the agent might have already done something irreversible before verification runs. Without pruning, your verification layer chokes on noise. Without cost guards, your failure recovery turns into infinite expensive retries. Without failure recovery, your sandboxing just means the agent fails politely instead of dangerously, but it still fails. Each layer protects the others. Build all 5, or you're building a system whose weakest layer determines its real reliability. This is why the demo to production gap exists. Demos are showing you layer 0, the model and a loop. Production needs layers 1 through 5. And every team that's actually shipping reliable agents has built all 5, often without giving them names. Once you have the names, you can audit any agent product and see which layers are present and which are missing. So here's what I want you to do with this. If you're building an agent right now, stop and audit it against these 5 layers. Sandboxing. What's the blast radius of your worst tool call? Memory. Who prunes your context and when? Recovery. What happens when a tool returns an error you didn't expect? Cost. What's your hard daily cap and your max steps per task? Verification. Who or what checks the output before you act on it? Write the answer for each layer. Wherever the answer is nothing or the model handles it, that's a layer you have to build. If you're evaluating an agent product to buy, ask the vendor about these 5 layers in plain language. The answers will tell you in about 10 minutes whether the product is a real production system or a polished demo. And if you're a developer trying to break into agent work, these 5 layers are the actual job. The model is the easy part. Anyone can call an API. Building the scaffolding around it is the work, and it's the work that's getting paid for. I'll keep going on this. I have a whole series on each individual layer planned, starting with sandboxing. So if this was useful, the channel handle is on screen. I'll see you